Let's see about the second law of thermodynamics, Kelvin-Planck statement. What is the statement? It is saying that it is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce an amount of work. So no heat engine have a thermal efficiency of 100%, or as for a power plant to operate, the working fluid must exchange heat with the environment as well as the furnace. The impossibility of having 100% efficient heat engine is not due to friction and other dissipative effects. It is a limitation that applies to both idealized and actual heat engine. So what Kelvin-Planck statement is saying that if you only have one thermal reservoir and you have an heat engine, you cannot produce work without releasing heat to the other reservoir, to the low thermal reservoir. So if you don't release heat, Q out, QL, it will be you receive heat 100 kilowatt and you produce 100 kilowatt work network. So this is not possible, or this is impossible. So heat engine, and this is a heat, we call it a heat engine that violates Kelvin-Planck statement in the second law. This is not possible to produce work. Okay, next, the other mechanical devices that convert heat to work or work to heat is a heat pump and also refrigerators and air conditioners. These two devices have a different objective. For example, for heat pump, usually you use when you have a warmer space outside, and the objective of heat pump is to supply heat to a warmer space, giving. But for refrigerator, this is different. But actually, it's the same function. You are taking out remove the heat from the refrigerator, inside the refrigerator, which is usually cold, and giving it a kitchen space. It's taking out, so the refrigerator is taking out the heat from refrigerator, whereas the heat pump is supplying heat to a warmer space. Okay, let us see the refrigerator and heat pumps. First, about the refrigerators. The transfer of heat from low temperature medium to a high temperature one requires special device called as refrigerators. And this refrigerator is like a heat engine. It is a cyclic device. And the working fluid used in the refrigeration cycle usually we call as refrigerants. And most frequently used refrigeration cycle is the vapor compression refrigeration cycle. This is the vapor compression refrigeration cycle. It transfer heat from low temperature, initially the refrigerant inside the evaporator, where usually it is a very low pressure and low temperature refrigerants inside the evaporator, will absorb heat from refrigerated space, and then it will cycle going to a compressor. So inside the compressor will be operated by electricity. So this is, we have a work in, and compressor will compress the working fluid. The working fluid pressure will increase, and the temperature will also be increased. So inside at the back of the refrigerator, where we have coil, call as boiler, it is the working fluid will release the heat to the surrounding medium, such as kitchen air, and that is why we call it as a condenser. And the working fluid will become lower temperature after releasing. It comes in an expansion valve where it expands. Due to the expansion, the working fluid will become lower pressure and lower temperature, and it goes back to the evaporator. Okay, the efficiency of refrigerator expressed in terms of COP, or coefficient of performance. In a household refrigerator, the freezer compartment where heat is absorbed, this is the refrigerator compartment, heat is absorbed by the refrigerants, serve as evaporator. And the coils, as I said just now, as coil behind the refrigerator, there's a coil behind the refrigerator, is where heat is dissipated or heat release here to the kitchen air. So this one serves as a condenser. The COP for refrigerator usually been calculated by QL per WNet. So this is desired output, as we learn, COP or efficiency, desired output divided by required input. So in a refrigerator, the desired output is QL, and the required input is WNet. But for heat pump, the desired output is QH divided by the WNet sim. Okay, the COP, we use COP instead of efficiency for heat pumps and refrigerator. COP be greater than 1 for refrigerators, can be greater than 1, so the COP can be higher than 1, but usually it will be less or same as 1. But for it is always greater than 1 for heat pumps. So for heat pumps, the COP usually is always greater than 1. For refrigerator, it can be less, it can be equal, but sometimes it can be. So Okay, let's see the COP, how the COP of refrigerator can be calculated. As I said just now, QL divided by W net, because the objective of a refrigerator is to remove QL. This one, this is the from the cold refrigerator space, and the desired output, required input is W net. So this is where we get, also the W net is QH minus W net. So this is where we get COP of refrigerator QL divided by QH minus QL, or the same as 1 QH by QL minus 1. For the heat pump, is different because the objective of heat pump is to supply QH into the warmer. So this is the desired output for heat pump, and this will be the required input. So that is why in heat pump the QL is QH divided by QH minus QL, or it is equals to 1 divided by 1 minus QL per QH. The work supply to us. Okay, next is the clauses statement. We have a clauses statement. After the Kevin Planck statement, we have clauses statement saying that it is impossible to construct device operate in a cycle and produce no effect other than transfer of heat from a lower temperature body to a higher temperature body. So what does it saying? That if you have two reservoirs, cold space and warm space, and a heat pump here, using the heat engine, but you don't have any work to the heat engine, there's no work, the net is equal to 0. So it is also impossible for you to transfer heat from a cold space to the warmer space, warmer environment. So this kind of refrigerator also violates the clauses statement of second law.